All right, ladies and gentlemen, we are continuing our discussion of mechanisms. This time we're going to do acid catalyzed hydration. And if you remember in our previous reaction, the first step was the reaction of the alkene with a strong acid. Oops, I had it right there. You know what I should have done? Should have had 2 copies of this for you. That's okay. React with a strong acid. Any other molecule doesn't react. You need a strong acid. Water's not a strong acid. Water will not react. The catalyst reacts first. Yes, a lot of people, they have the misconception that catalysts don't react because they say their biology teacher told them that. No, they said they don't get used up. They get reacted, but they also get regenerated. And when you're doing mechanisms, you actually see that. You will see sulfuric acid used in an early step and then regenerated in a later step to be used again in a cyclic nature. Use it, regenerate it. Now it can do the same thing the first sulfuric acid did in your mechanism with a separate molecule of your alkene. Use it, regenerate it. Now you can react a third molecule of alkene with a sulfuric acid because you regenerated it again. Ad nauseum. So in theory, you only need 1 sulfuric acid molecule for billions upon billions of alkene. That's all, because the acid keeps regenerating. But the most important thing is don't look for shortcuts. Yeah, you can get the mechanism done in half the time attacking water with the alkene pi electrons, but it doesn't happen because that's not a strong acid. You're inventing things. We do real things. We attack strong, oops, don't miss the strong acid though. Strong acid right there. So our catalyst is now being used. Later on, I better regenerate it or else it's not a catalyst, right? You get your 2 cations just like before. 90% of them are this cation, where the H went on the end and the plus on the tertiary. Carbocation. And the other one put the H on the middle carbon. By the way, I don't even need to see these H's in the mechanism, right? You can leave those H's off, right? The stick figure H's don't have to be there. But you're learning this for the first time. It's nice to know where the H went and then later on where the OH went. Okay, and when you made this, you generated hydrogen sulfate ion. That's one of your 141 ions, I'm pretty sure. Hydrogen sulfate. Don't use it now. It's a weak base, the conjugate base of a strong acid, so it's got to be pretty weak, right? And this one's our primary carbocation. As a result, minor yields minor, major yields major, but we don't know how we're going to yield major. How do you think the O gets on there? Where does it come from? It does not come from any kind of sulfate, people. HOH, you mean? Nothing's happening to the OH. We have to put it on. I have to make this molecule look like this one. I got to put the O on now. Where does it come from? What's the closest thing to OH over here? Of these 3 things, which one looks closest to being OH? Water is only different by a proton. So water is the attacker now. Does water not have lone pairs? It does. It attacks the carbocation carbon. Same thing here. Yeah, but we only need one for mechanisms ever. He asked, it has two lone pairs, right? But in mechanisms, I only need to see a lone pair if I'm going to use it. Keep that in mind. It's a hint why I drew this lone pair here. You're going to use it later. I'm still not 100% happy with this. I want that arrow to be clearly ending at the carbon atom. Yeah. It didn't move. It won't move. I like it. What do you get? You get something that's related to the two products. I tried to hit save. It's not responding. Bear with me. 5, 4, 3, 2, 1. Look at that. Oh, I really need to see those products too. That's what you get. And this is what you get. And I'm going to ask you, what's the relationship between this and the major product that it's about to become? What's the relationship between this and this? It's something we just studied recently, and it wasn't in chapter 5. What's the only difference between these two species? This one and this one. What's the only difference between those species? If you're focusing on this H, it's on this one too, so don't say that. What's the only difference between this species and this species? Say the word. The extra proton. What do we call species that are different by only a proton? Conjugate pair. What kind of reaction is that that makes one into the other? It had a name. It's the title of the chapter. Acids and bases, right? It's an acid-base reaction. Guess what's next? I just said it. I just said it. What reaction's next? Acid-base. Here's, which one of these two is the acid? The one on the bottom or the one on the top? Bottom needs a base to grab the H. And don't forget this word here, catalyst. We must also regenerate sulfuric acid. Can I ask the question again? What's the base? I must make sulfuric acid now. What's the base? Hydrogen sulfate is the base. When it gets an extra proton, guess what it is? Sulfuric acid, the catalyst. Back. Meow. Cat says meow. Catalyst. Cat. Sorry. I'm lame, I know. You'll see meow in a lot of videos and notes. Some people were tortured with it yesterday in lab. You got to live with your teacher, you know. There we go. Hey, the cat's back. I'm gonna write this down. The cat came back because this becomes, wow. No, it has to be a strong acid. He asked a very good question. Does any H is okay, right? Doesn't matter. Answer, no. Sulfate ion, hydrogen sulfate ion is not a strong acid. It will only be able to remove H plus from a strong acid because it's a terribly weak base. Okay, and that's an oxonium ion here. pKa strong. Right there. That's for this one. This one. And that one. They're both pKa -3. Okay, the cat came back. You should Google that right there. Google the cat came back and watch the cartoon. It is hilarious. That's all I'm going to say. You don't have to, but it's a lot of fun. It's about a cat, not about a catalyst, but yeah, you got to put up with me. I'm sorry. And that is the hydration. That's catalyzed. And that's the end of our video right there.